Let's do a problem from section 5.3, which is solving nonlinear systems. So again, this is from section 5.3, and it is problem 22. We are asked to solve the system x squared plus y squared equals 25, 2x minus 3y equals negative 6. So we're actually going to solve this algebraically, but what I want to do is sketch a quick graph that'll help us get an idea of what to expect. The graph doesn't have to be perfect, but let's see, x squared plus y squared equals 25. That's a circle, the center at the origin, with a radius of 5. Our graph doesn't have to be perfect because we're not solving this problem graphically, but I want to get an idea of what to expect. So I'm calling that a circle, a radius 5, centered at the origin. And also what we have is this equation here, 2x minus 3y equals negative 6, which is a line. And what we can do is we can use just the intercepts to graph the line. Remember, to get the intercepts, you set the other variable equal to 0. So if y is equal to 0, we get 2x equals negative 6. So x is equal to negative 3. And if x is equal to 0, we have negative 3y equals negative 6. So y is equal to positive 2. Again, all it takes is 2 points to determine a line. So when we graph both the equations, we see that they cross in two places, once in the first quadrant and another time in the third quadrant. So our solutions will be right here and there. We're going to get one solution in the first quadrant and another solution in the third quadrant. So let's go back to our system. What we're going to actually do is we're going to solve this algebraically. So again, we had x squared plus y squared equals 25. 2x minus 3y equals negative 6. So with a nonlinear system, there's no systematic way of approaching the problem the way we do with linear systems. So pretty much anything goes, but for the most part, it's going to be substitution. So looking at these equations, I think it's easier to do the following thing. Let's solve equation 2 for x. So to solve equation 2 for x, what we would do is we would add 3y to both sides and then divide both sides by 2. So take a minute and do that. And what you should end up with is x equals 3/2 y minus 3. Now you take this result and you're going to substitute x equals 3/2 y minus 3 into equation 1. So remember, equation 1 is x squared plus y squared equals 25. So what we have is 3/2 y minus 3, the quantity squared, plus y squared equals 25. So we're going to expand this right now, or 4. It's 3/2 y minus 3 times 3/2 y minus 3 So if you expand that out, and again, take a minute to verify this, you have 9/4 y squared minus 9y plus 9 plus y squared equals 25. So what you should notice now is we have one equation involving only y, and it's going to be a quadratic equation, which hopefully we're going to be able to solve. Okay. So we're going to combine like terms. 9/4 y squared plus y squared. Think of this as 1 y squared, which is 4/4 y squared. So when you combine like terms, you end up with 13/4 y squared. And I still have minus 9y. And when I subtract 25 from both sides to get this equation into standard form, what I get is, let's see, 9 minus 25 is negative 16. So here's where we are right now. We have 13/4 y squared minus 9y minus 16 equals 0. We're making progress. I think what we want to do is clear the fraction by multiplying both sides by 4. So let's do that starting on the next page. Starting on the next page, again, we'll copy down what we just had, which is 13/4 y squared minus 9y minus 16 equals 0. Multiplying both sides by 4, we end up with 13 y squared minus 36y minus 64 equals 0. Now you're free to use the quadratic formula, but I wouldn't necessarily do that. I think this can be factored. I just have a feeling about that. Let's try to use the AC method. 13 times negative 64 is negative 832. So we're going to use a little bit of trial and error here. What we want are factors of negative 832 that add up to negative 36. Now, I think the numbers that we want are negative 52 and a positive 16. Let's verify that for a minute. Is it true that negative 52 plus 16 is that negative 36? The answer is yes. So what that is telling us is I'm going to rewrite this trinomial as a 4-term polynomial. I have 13y squared and negative 36y. What I'm going to do is I'm going to write that as negative 52y plus 16y minus 64 equals 0. Now we have 4 terms, we're going to factor by grouping. Factor by grouping. So from the first 2 terms, I know I can take out a 13, because I know that 13 times 4 is 52. So I actually can take out a 13y. So I have 13y times y minus 4 plus, from the second 2 terms, I can actually take out 16. So I have 16 times y minus 4. So notice what happened. Now I have a common binomial. That's really good. So if we continue factoring, what we end up with is y minus 4 times 13y plus 16 equals 0. Y minus 4 times 13y plus 16 equals 0. Let's copy that down on the first line of the next page. We're going to finish the problem. So again, what we have is y minus 4 times 13y plus 16 equals 0. So what this is telling us is that y is equal to 4, or y is equal to negative 16 thirteenths. Now we're not done yet, because remember what we want to do, we want to find the ordered pairs, x, y. We found the y values, 2 of them. And notice that one of them is positive and one of them is negative, as expected. So, remember what x is. We found x in terms of y earlier in the problem. X is 3 halves y minus 3. So, if y is equal to 4, well, let's see now, 4 over 2 is 2, 2 times 3 is 6, 6 minus 3 is 3, or x is equal to, again, I'm going to replace right here y with negative 16 thirteenths. So if I multiply that by 3 halves, 16 over 2 is 8. 8 times 3 is 24, so I get negative 24 thirteenths minus 3, but 3 is 39 thirteenths. So if you combine those, you get x is equal to negative 24 minus 39 thirteenths, which is negative 63 thirteenths. So if what I'm saying is if y is equal to negative 16 thirteenths, then x is negative 63 thirteenths. So let's write down our solution. Right, as the solution said, we have 2 ordered pairs. Right, we have the ordered pair 3, 4, because if y is 4, x is 3, and vice versa. And we have the ordered pair negative 63 thirteenths, negative 16 thirteenths. And again, notice what we have. We have 1 point in the first quadrant and 1 point in the third quadrant, which we expected. So the graph helps us know what to expect. Okay, so again, our solution are these 2 ordered pairs, 3, 4, and negative 16 thirteenths. I'm sorry, negative 63 thirteenths, negative 16 thirteenths. Those are the 2 ordered pairs where these graphs cross.